right, so using similar triangles. In using similar triangles, we need to determine how we're going to figure out whether or not they're similar. And to do that, it's all about the angles. So let's look at some similar triangles. These are intended to be similar, not perfectly drawn to scale. But one important thing is, yes, the triangle looks like it got larger, but the angles remain the same. And that's a very key fact about any similar figures. So in specifically triangles. So you have a 95-degree angle here. This one will still be 95 degrees if they're still similar. If this one's 65 degrees and they're similar, this one will also be 65. If we have a 20-degree angle here, this one will also keep the measurement of 20. So these are corresponding angles. Corresponding, remember, means matching. So if you have, in this case, 3 pairs of corresponding angles, 95 and 95 are corresponding and they're congruent. 65 and 65 are corresponding and they are congruent. 20 and 20 corresponding and congruent. Now, we don't need all 3 of them to be congruent, because if 2 of them are congruent and matching and the same, then we definitely have similar triangles. There's no need to check the third. So let's write that down. If 2 triangles have at least two corresponding congruent angles, then the triangles are similar. All 3 angles will be congruent, but if you're trying to verify and check, you really only have to check 2. And then by default, the other ones will also be congruent. So we would say these 2 triangles are similar because they have congruent corresponding parts. All right, so let's look at an example. Are they similar? And we're going to be talking about angles in A, then we'll have another one B and C. So let's look at this triangle. So let's say this one is 75 degrees. This one's 50. And I don't know what X is. And then I have another one, not drawn to scale. Say this is Y, 50, and 75. Now, we need to check if we have 2 pairs of congruent corresponding angles. Well, as of right now, I can see I have 50 and 50. Those are congruent and they're corresponding. So I have 1 pair. And I have another pair here, 75 and 75. So I do have 2 pairs of congruent angles, so they are similar. Now, we don't need to check the third angle because, again, by default, if you have 2 of them congruent, then the third ones will definitely be congruent. So what we actually need to conclude is that angle X will actually indeed be exactly the same measurement as angle Y. There's no need for us to figure that out. We already know that if they add up to 180, we'll indeed get the same number there. And let's try another one. And when you have similar triangles, one of them will always appear different size than the other, unless they're identical, and that will mean that they're congruent. So we have a 63-degree angle here. We don't know this angle, we'll call it X, and a 54-degree angle here. This one we'll call angle Y, 63 and 63. So are these congruent? Do we have two pairs of congruent angles? So let's check. We have one pair. I see we have 63 and 63. Now I just need to check one more pair. It's possible that this one's 54, and that would say yes. Or it's possible that this one's also 63, and then I can say yes. But we won't know for sure until we find one of those missing angles. So we're going to use what we previously know, which is if you have two angles, you can find the third one. So let's find X. So let's do that. So X plus 54 plus 63, we know should all equal 180. And that leaves me with X plus 117 equals 180. Subtracting from both sides, you get X equals 63. So if this X equals 63, I have my other pair. So I can say that I have this one and this one are another pair of congruent angles. So the answer is going to be yes. Okay. And that means by default Y would also have been 54, corresponding to this one here. And one more example. So we have angle X here, a 90-degree here, and a 42-degree here. And I got a bigger right triangle here. And I'm going to call this one Y, 90, and 38. The question is going to be, are these similar? Again, I'm looking for two pairs of congruent angles. If you recall, this means 90 degrees. This means 90 degrees. It doesn't look like it's labeled, but it is. And these two are congruent. I'm just drawing the line extending so that we know we have a pair of matching angles. And now we got to check to see if this one is either 38, I can say those match, or if this one's 42, and I would say those match. So again, you're going to try to find one of the missing angles, and on this one I'm going to try to find X. So I know that X plus this angle here, 90, plus 42 is all going to equal 180. And doing this, simplifying these by combining like terms, you get 132 equals 180. When you subtract 32 from both sides, you get 48. So that means angle X is 48. So if this is 48 and 42, neither of them are going to be congruent. I mean, yes, so we only have one pair, so the answer is no. All right, so if you're thinking, why don't we check if Y is 42? Well, if we already know that 48, 42, and 90 make 180, we have here that 90 and 38 and a third angle will have to be something other than 48 and 32. There's no way we can get a 42 here, because if we did, that would make this one having to be 48. So that's not possible. All right, so if you're given a set of triangles and you want to know if they're similar, you just have to make sure you have two matching congruent angles. And in this case, we didn't. And there you go. All right, so let's look at example 2. For example 2, we have two triangles. They are both 90-degree or right triangles with 90 degrees. And we were given this is 60. This side is 50. This side here is 40. And I want to know what x is. So the instructions will be to find x. Now, we need to identify these as similar triangles. The only way I can start setting up a proportion with my corresponding parts is if I'm going to assume that these triangles are similar, meaning they're the exact same triangle, just different sizes. So what we've learned in the past are if you have two pairs of congruent angles, we can conclude that these two triangles indeed are similar. So I have a pair here. I can see that 90 degrees on both triangles, so those are corresponding parts and they're congruent. And I also have another pair here. Well, there is no label here, that we don't know the measurement of these angles, but because they are created with two intersecting lines, I know these are called vertical angles. And because I know these are vertical angles, they're going to be congruent. So I know that's the second pair of congruent angles, I'm sorry. So we're going to conclude that these are similar. Now it's important that we conclude that they're similar before we can assume that the ratio of their sides are proportional. So now because we know they're similar, we can say that x on this triangle, it appears to be the height of the triangle if you turn it around at the 90-degree angle, will correspond to 60, what looks like the height of that triangle when you're looking at the 90-degree angle. So x will correspond to 60. And then again, we have another ratio of the proportional sides, which will be, let's look at 40. So again, turning it over, 40 looks like it's the base of that 90-degree right angle or right triangle. And that one's going to correspond to, looks like 50, the base of that triangle. So it's very important that you actually do find the corresponding parts. Sometimes you'd have to turn the paper over, imagine them being reflected, turned around, rotated, because not all shapes are going to be sitting on their bottom. So we were able to identify the matching parts. So now we're going to cross multiply and solve for x. 40 times 60 makes, 6 times 4 is 24, so that makes it 2400. And 50x. And now when you're solving for 50, divided by 10 on both, you get this, and then 240 divided by 5, that gives us 48 equals x. So that means this distance here is 48. And again, anytime you want to assume or make the assumption that you have corresponding parts that are proportional, you must first check if your triangles are similar before you make this assumption. There you go.